this video, we're going to look at the mechatronic components of our new glider prototype. First, let's look at the electronic components. For our controller, we decided to use the Arduino Uno. It has a large community of developers behind it, which have produced a library for almost any peripheral you might want to add to it. It's also small enough that it can be readily used in an embedded system. The Arduino then uses a pair of half-H bridges to drive the motors. The motor is then hooked to a 200-to-1 gearbox, which drives a pinion, which in turn drives a rack, which pushes the water in and out. A pair of limit switches is then used to detect the front and back positions of the syringes. All these components are wired to the Arduino using a solderless breadboard that allows easy debugging when the circuit doesn't work. The entire circuit is then powered with a 9-volt AA battery pack. Next, let's look at the circuit and code required to make the glider actually work. This is the circuit diagram for our control system. You can see pins 5 and 6 are hooked to the inputs of the two half-H bridges on this side of the chip. The motor is then hooked between the outputs of the two. This makes pin 5 drive the motor forward and pin 6 drive the motor backward. Next, let's look at the code that actually runs on the Arduino. This is a picture of the Arduino development environment. Code that you write here can be compiled and then uploaded to the microcontroller. From there it can read the inputs from the switches, write outputs to the motors, and generally run the entire control system. We'll go through the details of exactly what this code does later. Now we're going to go through a demonstration of the glider in action. We start with the glider unpowered. You then have to plug the battery pack into the microcontroller. The microcontroller then will regulate the 9 volts down to its native 5 volts and start running. It starts by setting up the input and output pins and the PWM for the motor controller. It then energizes the gear motor and begins drawing water into the syringes. It will then continue drawing the water in until it hits the innermost switch. Here you can see that code running on the actual glider. You can see as the rack is drawn in. And here you get a larger view, showing how the switch stops the motion of the gear. So the control system then stops the motor and lets the glider glide to its final depth. Next, it reverses the process, energizing the motor to drive the water back out. So now, you can see that code running in the actual glider. The rack moves out, pushing out the water. Here, we go over the same thing again, starting with a side view so you can see it moving from the full in position to the full out position. The motor then stops when it hits the switch. And here, you can see the code which actually makes it stop while it glides to the surface. This basic cycle of the control system and the mechanical components will repeat itself over and over again as the glider moves up and down through the water. The control system cycle controls the motor by calling these three functions in succession. The water out, one that draws it in, and one that stops the motor. Thank you for watching the video.